This tutorial presents DriverAuth, a tri-modal authentication solution for smart enterprises for the safety and security of customers. This research work is a part of my Ph.D. dissertation titled, Next Generation User Authentication Schemes for IoT Application. Also, we published in a paper titled, DriverAuth, a risk-based multimodal biometric-based driver authentication scheme for ride-sharing platforms. And, DriverAuth, behavioral biometric-based driver authentication mechanism for the on-demand ride and ride-sharing infrastructure. On-demand ride and ride-sharing services have revolutionized the point-to-point transportation market. Alone, Uber and Lyft are providing over 18 million plus rides per day. The driver's reliability has emerged as a critical problem. An increasing number of misconducts by drivers are reported every day, worldwide. A number of issues related to riders' safety and security have started surfacing. A robust driver verification mechanism is required. DriverAuth is a novel risk-based tri-modal biometric-based authentication solution that uses swipe, text-independent voice, and face modalities for a driver authentication. We consider the threat model where the adversary can impersonate a driver partner by imitating a legitimate driver. The attackers collude with a legitimate driver partner providing rides on behalf of the legitimate driver. Thus, DriverAuth ensures the on-demand ride and ride-sharing services safer and more secure for riders. Customers can also report about malicious, fake drivers. In most cases, on-demand ride and ride-sharing services use simple verification mechanism, in which, driver partners are verified at the time of entry only, and driver partners are considered legitimate until they quit the system. But, the main risk to the safety and security of customers lies when they book the ride. Therefore, it is essential for service providers to authenticate the drivers before they are assigned a ride assignment. The lack of robust driver verification mechanisms has opened a room to an increasing number of misconducts, that is, drivers subcontracting ride assignments to an unauthorized person, registered drivers sharing their registration with other people whose eligibility to drive is not justified. DriverAuth offers a real-time driver authentication mechanism at the time customer books a ride. Thus, it can address an increasing number of customer abuses reported every year. In 2018, Uber has introduced a real-time ID check, a face recognition system developed by Microsoft, to verify the identity of their registered drivers. Only a subset of randomly selected driver partners are asked to verify themselves, and this is not during the time they took the ride assignment. For related work, we studied multimodal user authentication systems for smart devices that use similar biometrics as ours. The Proteus system used face and voice features. Principal components using principal component analysis and MEL frequency Kepstrel coefficients for face and voice modality was extracted. They achieved an equal error rate of 2.14% using latent Dirichlet allocation on a dataset of 54 users. Corman leverages voice, face and signature modalities, for user authentication on mobile devices. They achieved the EER of 2% Gaussian mixture models on the audiovisual database and Biomed online signature database. Fung presented a finger gesture-based authentication system called it FAST. The system extracted 53 touch features and achieved a FAR of 4.66% and FFR of 0.13% on a dataset of 40 users using gesture sequence-based authentication. Liveness detection is generally deployed to detect spoofing attacks. Zhang proposed a voice gesture system that achieved 99% detection accuracy at approximately 1% EER. And they demonstrated that mobile audio hardware can be used to exploit the articulatory gesture of a user to detect liveness. We developed a customized Android application to collect swipe gestures and voice data. We outsourced the data collection activity to UberTesters, a crowdsourcing platform, to collect these two modalities in the wild, that means in an unsupervised environment. We collected 10,320 samples 3 days with 1 session per day. For face data, we relied on the mob.io database. We augmented them to form a single dataset as these three modalities are mutually independent of each other. The dataset contains the data from 86 users, having 56 males, 29 females and 1 undisclosed. You can observe the slide for more information related to the collected data. For swipe, we extracted 33 statistical features that are min, max, average, standard deviation, and variance. From velocity, acceleration, and pressure values obtained for each touchpoint from a swipe gesture. Also, we calculated distance, duration, average touch size, start and end touch points. We acquire a voice data of 2 seconds that contains 2 channels sampled at 44.1 kHz with 16 bits per sample. From this voice signal, we calculated MFCCs, which is a 2D vector of size 13 cross number of coefficients of variable length. MEL frequency Kepstral coefficients are analogous to filters vocal tract in the source filter model of speech. From each MFCC vector, we computed 4 statistical features, namely, mean, standard deviation, kurtosis, and skewness. So one channel we get 52 features, thus, for both left and right channel, we get 108. From the face image, we get the region of interest by cropping the original images. And then from a cropped face image, we extracted binarized statistical image features filter to obtain statistical features. We get 256 features per image using the filter of size 3 by 3 pixels with 8 bits word length. We concatenated the feature sets of each modality together to create a single feature set of dimensions 393 for evaluation of DriverAuth in tri-modal settings. For feature selection, we relied on the relief-based selection method provided by the MATLAB tool. We selected the top 51, that we determine empirically. And using these selected 51 features we designed the classification model. Data fusion in a biometric system is a process of integrating multiple modalities to produce more accurate, consistent, and comprehensive information of users. Biometric researchers often consider that early data fusion increases the accuracy of the system. Feature-level fusion is a better choice to improve the accuracy of the system because feature representation reflects more relevant information on users. Lastly, this setting is preferred as it combines independent modalities. Feature selection plays an important role in the fine-tuning of the chosen classifiers. It helps in reducing the dimension of data as well as prevent the overfitting by identifying productive features out of the full feature set. This process not only maximizes the accuracy of a classifier but also contributes to improving classifiers' decision-making time. We will see the details of the classification model in the next slide. In the slide, I am only presenting the validation results of the classification model using the holdout method. Otherwise in the paper, one can see the validation results in unimodal, and bimodal settings, by using cross-validation as well as the holdout method. We designed a multi-class classification model using MATLAB Prtools. And used Quadratic SVM, Ensemble bagged tree, weighted KNN classifier. Ensemble bagged tree classifier gives the best TAR of 96.48% at FAR equals 0.02% with 15 training samples on selected feature set obtained by the relief-based feather selection method. If you have any question, please write the comment. Thank you for watching the video. Please subscribe to my channel and like the video.